In this video, we are going to discuss another math problem.
Now, circle is a set of all points equidistant from a fixed point called center. So given here our illustration of circle and its parts, let us identify the different parts of the circle. So let's start with the center. So as we can see, this is the center, which is point H. And then the name of the circle is named after the center. So this is named as circle H. Now for the radii, which is the plural of radius. So this is a segment connecting the center of the circle and a point on the circle. So we have segment SH and segment EH. Now for the diameter is twice the radius, or by definition it is a segment connecting any 2 points on the circle provided that it passes through the center. So here it is segment ES or SE. Now for the chord, so chords are segment which passes which connects two different points on the circle. So here we have segment SP and then segment EP. Of course, the diameter is the longest or the largest chord, but since we already put here the diameter, so this is a special type of chord, the diameter. Now, let's have the second line. Second line is a line that passes through any 2 points on the circle. So in this case, here we have line SP as the second line. Tangent line. Tangent line is a line that intersects the circle at exactly 1 point. So here, this is line AS. And the point of tangency is point S. Now, let's identify also interior points. So interior points are points inside the circle. So those are point R and point H. So those are the interior points. The exterior points are the points outside the circle. So there's only one, that is point A. And of course, there are points which lie on the circle itself. So those are point S. Of course, that is the tangent, the point of tangency. Point P. And point E. Now this time, let us discuss arcs and angles of a circle. So given circle M, so the name of the circle is circle M. Of course, the center is M with radii AM and MB and diameter AB. Now let us identify the different arcs. Now arcs is defined as a part of the circumference of a circle. And to find for the minor arc, we should always remember that minor arc is less than a semicircle. So less than a semicircle. So here, the minor arcs are arc AD, arc DC, and arc BC. So it is denoted by two capital letters. It measures less than 180 degrees. Now, for major arc, it is an arc which is greater than a semicircle, and we use three capital letters. So example of this, we have major arc A, B, C. It is more than a semicircle, more than half of a circle. We also have major arc A, B, D. Okay. We also have major arc DAB, major arc DBC. Okay. Now for semicircle, it is exactly equal to 180 degrees. It is the half of a circumference of the circle, which is just like the protractor. So here in our example, this is, we can put point here, yes, because semicircles usually use three capital letters as well, just like the major arc. So we have semicircle AEB and semicircle ADB or ACB. Okay, now for angles, so as you can see, there are three angles formed here. So for central angle, from the term itself, the center of the circle is the vertex. Okay, so the vertex here is the center. So central angle AMD and central angle BMD. So those are the example of central angle. Now, for inscribed angle, this is actually an angle which is formed by two chords, and the vertex is a point on the circle. So here we have inscribed angle ABC. Now this time, let's have the degree measure of an arc. So we have three kinds of arcs here. We have minor arc, major arc, and semicircle. So always remember that the measure of the central angle is equal to the degree measure of its intercepted arc. So here, if the measure of angle AMD is 50 degrees, so the measure of its intercepted arc, minor arc AD, so the measure of minor arc AD is also equal to 50 degrees. Okay, now for the major arc, so the degree measure of a major arc is equal to 360 degrees minus the measure of that minor arc with the same endpoints. So if we are going to get the measure of major arc ABD, so you have measure of major arc ABD. Since we all know that the measure of arc AD is 50 degrees, so we just subtract 360 degrees and 50 degrees. So therefore, the measure of major arc ABD is 310 degrees. Okay? Now, to find the measure of the semicircle AEB, so of course, semicircle is half of the circle. So and one revolution is equal to 360 degrees, so therefore the measure of the semicircle is 180 degrees. Always remember that the measure or the degree measure of the semicircle is always equal to 180 degrees. So this time, let's have the arc addition postulate. So it states that the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So if we are going to get the measure of arc DE, arc DE, so this arc actually consists of arc DA and arc AE, and we need to add them. So if we're going to do that, so that is 50 degrees plus 70 degrees. So therefore, the measure of arc DE is equal to 120 degrees. Now, let's have another example. If we are going to get the measure of arc DBE. So we need to get the sum of arc DB, which is 130 degrees. So measure of arc DB and added to measure of arc BE. So that is 130 degrees plus 110 degrees. So you have 240 degrees.